All right, this is 8th grade lesson 2.1, integer exponents. So you last year really worked on, and the beginning of this year worked on refreshing memory on integers and what they mean. And it is that base multiplied by itself that many times, that exponent amount of times. So this lesson is going to start talking to us about what happens when these things happen. And maybe you remember what this one is, but you probably don't know what these are. So I'm going to walk you through it. Once you see the pattern, it all makes easy sense and you're all good to go. So just a reminder, so 5 to the 4th power means 5 times 5 times 5 times 5. 5 times itself 4 times. So if you calculated that all out, you would get 625. 5 to the 3rd power, 5 times 5, which is 25, times 5 again, 125. 5 to the 2nd is 5 times 5, which is 25. 5 to the raised to its 1 power is just itself. That 5 base sitting there all by himself, 5. 5 to the 0 power is that starting point. We have not started multiplying anything, so it's the identity property of multiplication. It's just a 1. So anything to the 0 power is 1 because it's our starting point. It's whatever times 1 will be what comes next. Okay. So, and I know that's a weird one because a lot of people think it should be 0, but we're not doing 5 times 0 or 4 times 0. It's our starting point. It's this number will be waiting to be multiplied by that base when it's time. Okay, so what happens if I have these negative exponents? Super easy fix. Once you see it, you'll be like, oh, that's it. Yeah, that's it. It's just like moving decimals around anyway. It's the fractional version of it. So I could rewrite this 5 to the negative 1 as 1 over 5 to the 1 power, which is the same as 1 over 5. I could rewrite this 5 to the negative 2 power as 1 over 5 to the 2nd, which technically 5 to the 2nd, of course, is 25. So I could just rewrite it as 1 over 25. And that's all. So you just reverse it into a fraction because now you are looking at decimals moving opposite directions and things like that. So you reverse it into its fraction, and now you're getting that decimal version of it because it's a smaller than whole number is what's happening. That's what a fraction is. So let's look at that again and see if what our brains are thinking is happening is exactly what's happening. 4 to the 4th, 256. 4 to the 3rd, which is 4 times 4 times 4, 64. 4 to the 2nd, which is 4 times 4, is 16. 4 to the 1 power is 4. 4 to the 0 power means we're just at the starting point of 1, waiting to be multiplied by that base. 4 to the negative 1, you guessed it, is just 1 over 4 to the 1, which is also just 1 over 4. Because over here we notice 4 to the 1 is just 4, so that's it. And 4 to the negative 2nd power is just 1 over 4 to the 2nd, which we know 4 to the 2nd is 16, so we can rewrite that as 1 over 16. And that's all it says. So you probably can work even faster than me to get the next row, but I'll go ahead and put it in for you. We've got 3 to the 4th is 81, 3 times 3 times 3 times 3. 3 times 3 times 3, 3 to the 3rd, 27. 3 times 3, which is 3 to the 2nd, is 9. 3 times nothing else, just 3 to its 1 power is 3. 3 to the 0 power is at a starting point of 1. 3 to the negative 1. You got it. 1 over 3 to the 1 power. That negative exponent is what stays on there, but now it's down here, so you can call it now a positive exponent. And that's just 1 to the 3rd. And this one is 1 over 3 to the positive 2nd now as the denominator. That to the 2nd now becomes a positive now that it's part of the denominator. And that, of course, can be written as 1 to the 9th. And then in this lesson, you're going to get all kinds of cool rules that you can use to help make math with exponents much easier. So we'll go through each of the rules and how and why they work. But then you're going to want to have maybe put a Post-it note on page 36 for properties of integer exponents in the purple box. That will be useful to refer back to for the next couple of lessons and for math in general for as you get further in, because until you get used to what these things these shortcuts are, it's nice to be able to refer back to it because you'll get ahead in another lesson and say, oh, there's a rule for that, and maybe not exactly remember the rule. You can go back and glance at it. That's right, I can add those together, and you're good. So let me show you, let me introduce you to these properties, these rules that we can use to manipulate the math to make it easier when we're dealing with exponents. First one, they're going to show you what the rule is. But before we show you what the rule is, we're going to show you why it works. So as you well know, if I have 3 times 3 times 3 times 3 times 3, we've learned that the shortcut for that is to just write that as 3 to the 5th, right? There's 5 3's being multiplied together, 1, 2, 3, 4, 5, 3 to the 5th. Shortcut, right? So it's not so much to write down. Something that I want to point out to you is if I regrouped this and I said, okay, I'm doing 3 times 3 times 3 times 3, and all of that times 3 as well. I'm still multiplying 3 times 3 times 3 times 3 times 3, but I've grouped them like this, where it's kind of like 3 to the 4th times 3 to the 1. But I'm still really doing 3 to the 5th power. 4 plus 1 is 5, right? Okay. Or I could have regrouped it 3 times 3 times 3 times 3 times 3. And I'm still going to get 3 to the 5th, right? That's still 3 times 3 times 3 times 3 times 3. Still going to get 3 to the 5th. Really, this is 3 to the 3rd times 3 to the 2nd. 3 plus 2 is 5. 3 plus 2 is 5. Hint, hint. So because that can happen when you have the same base, let's say whatever the base is, let's give the base the name of A, just because it can be any base. As long as it's the same as whatever you're multiplying it by, whatever exponents they have, let's call this exponent n and this exponent n. For example, the same base 3, so A in this scenario is 3. Then we had an exponent of 3 and an exponent of 2. And what happened was we just added those together, whatever they were, and that gave us that shortcut. So this is called the product of powers property. So if you have, you're doing a product of a base and you have the different powers put together, to simplify it, you can just add these two together. So that's a shortcut that you'll find useful in the next level of math. That's one of the things they show you. And it is stated on page 36 in your book. Let's look at another. So what if we were looking at 4 to the 5th power divided by 4 to the 3rd power? And keep in mind, all of these little tricks only work if our bases are the same as one another. So let's write this out so we can see why what we're going to learn about works. This is the same as 4 times 4 times 4 times 4 times 4. 5 fours, right? And the denominator is 4 times 4 times 4. Okay, so if I wrote it out that way, I could simplify this down a little bit, right? Because isn't 4 divided by 4 1? So that really, and anything times 1 is its own self, identity property, right? So this kind of cancels out. So I'm going to cancel that out. And then here I am faced with another match. 4 divided by 4 is 1. So those kind of cancel each other out. And again, 4 divided by 4 is 1. So those cancel each other out. And that leaves me with 4 to the 2nd power. And since there's only that 1 under there, the 4 times 4 times, it's gone. So it's just over 1. They've all been eliminated down. 4 divided by 4, 1, right? All right. So I could just write that as 4 to the 2nd power. Well, let's look at what happened with these exponents. I had an exponent of 5 divided by an exponent of 3, and I ended up with an exponent of 2. And so what calculation can I do to 5 and 3 in order to end up with a 2? I can subtract, right? So 5 minus 3 is 2. So it makes us wonder, Ms. Sanchez, are you telling me that if I have division of my bases, let's say my base is A, and A, in this case it was 4 and 4, but whatever the number will be, and I have an exponent of some number, this one different from this one. This case it was 5, in this case it was 3. That all I have to do is say, I'm going to take my base, leave it as a base, and I'm going to subtract and find the difference between the two exponents. Yep, and that is called the quotient of powers property. So let's see it in action a little bit. Let's do another one like it, and we'll play it out so you can see it again, because I think the more you see it, the more it starts to make sense. Let's say I have 6 to the 8th power over 6 to the 3rd power. They're telling me that if I have that going on, I can just subtract my exponents, 8 minus 3. So they're saying you're going to get an answer that's base 6. The base isn't changing, but I'm going to do 8 minus 3. And that equals 6 to the 5th power. Let's test that out. Let's go ahead and write these out just so our brains can see it, so we can convince our brains. 6 times 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 6. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. And then as my denominator, 6 times 6 times 6, that was 6 to the 3rd power. Cancel out my ones that divide by 1. So I've got match, match, match. Leaves me with 1 at the bottom as my denominator. And I have 1, 2, 3, 4, 5 6s on the top left. So that means I have 6 to the 5th power. So there's a trick for you, is you can simply, if you're dividing these exponents, as long as your base is the same, that's the rule for all of this, your base has to be the same. We can't do it with different bases. I can't say, oh, this is 6 to the 8th and 7 to the 3rd. Now I can't do this trick. The base has to be the same. Then I can just subtract those and done. I don't have to multiply them all out, get this ginormous number, and then divide it all. It's just a nice clean trick. All right, let's look at another exponent trick up our sleeves. Sometimes you see problems that are written like this. This is 5 to the 3rd power, 2 groups of them, right? So let me write that out so that our brains know exactly what this means. This is 5 to the 3rd power, 5 times 5 times 5. That's what this part means. But this part on the outside of this parenthesis means that we're talking about 2 groups of these. So we need to write down another group. All right, so there we have it. That is 2 groups of 5 to the 3rds, 2 groups of 5 to the 3rds. And our base is the same, of course. On all of these, our base needs to be the same for these tricks to work. How many 5s do I have here that are being multiplied together? 1, 2, 3, 4, 5, 6. So that equals 5 to the 6th power. So I had inside the parenthesis an exponent of 3, outside the parenthesis an exponent of 2, and I put those together and end up with 6. What calculation do I do with 3 and 2 in order to get 6? I multiply them, right? So the power of a power property is where I take a base that is the same. Let's say A, again, in our scenario here, the base was 5. And I have it set to a certain power, M, let's say. In this case, it was 3. And I raise that grouping by a certain power. In this case, it was 2. When that happens, the trick we can do, instead of writing it all out to find out, is we learned from somebody showing us, like I'm showing you now, that we can go ahead and just write it as a to the m times n to get whatever the answer is. For example, if I have 7 to the 2nd power, all raised to the 4th power, according to this rule, A is my 7 now, the exponent here is 2 and the outer exponent is 4, according to this rule, I can relook at this as 7 to the 2 times 4 power, which is 7 to the 8th power. Well, let's make sure. Let's let our brains make sure. Let's write it out like we did here. But this is how you would use the trick, and when your brain is comfortable with it, then you know, okay, I'm not going to write them all out. I'm just going to multiply these because I know power of a power property, right? So, but let's, for your brain's sake, let's write that out. Again, this is 7 to the 2nd power, which is 7 times 7. And I have 4 groups of those. So I'm going to go 1, that's 1 group, 2 group, 3 group, 4 group. And look at that, 1, 2, 3, 4, 5, 6, 7, 8, 7 to the 8th power. So this just serves as the shortcut for when you find those, that you can just go, oh, instead of writing them all out and counting them all up, this is how that works out. And that's how it works out. The next trick up our sleeve is called power of a product property. It's just another way, again, to manipulate the numbers to work for you as you get into the different, more complex things that we'll start to see. Having these tools in our toolbox become very helpful. So if you're looking at 3 times 4 grouped together, all to the 2nd power, really what we're looking at is 3 times 4 times 3 times 4, 2 groups of those, right? That's what this exponent means when it's hanging out on the outside of your exponent. And it's all multiplication as my operation, so I can use the commutative property to move it all around, or I can use the associative property to regroup things in a better manner, because associative property of multiplication lets me regroup things. So I'm going to regroup the 3's together and the 4's together. And then I'm just going to rewrite this as 3 to the 2nd power times 4 to the 2nd power. Because maybe I need my 3's with their exponent only, so I can do some other tricks with it to simplify my math, or my 4's with their exponent only, and not having it grouped together. So if you have this, you can rewrite it this way. Also, I kind of view it as the distributive property distribute the 2nd power to that and to that. So I guess you could look at it that same way. So the rule that they give us in the AMN kind of form is whatever my base is, we'll call it A. And if I have another base different from A, we'll call it B. Raised up to the n power, whatever that power might be. In our scenario, our A was represented by 3, our B was represented by 4, and our N was represented by 2. We're using letters because it could be any number, right? It just can't be the same number here. All right, so that rule states that this is the same as writing A to the n power times B to the n power. So basically, attaching the n power, whatever this exponent is, attaching it to both, and that will work. So let's have a look at that working then. As an example, if I have 5 times 6 to the 3rd, I can rewrite that as 5 to the 3rd power times 6 to the 3rd power, and that's all that rule extends to us. All right, let's take this into consideration with now all of these rules and tricks into consideration when we are looking at clearing or simplifying an expression. So I'll remind you, order of operations, PEMDAS, parentheses get cleared first, exponents get cleared next. Multiplication and division happen at the same time, whichever shows up for you from right to left. Add and subtract after that, whatever happens first from right to left between those two. So I'm going to go through and clear my parentheses. It's add or subtract in there. It's not an exponent issue, so I'm going to go ahead and subtract 5 minus 2, which gives me 3. I'm going to keep that exponent on there because I really didn't do anything with that, did I? I didn't do anything with this guy. I've got this exponent here. 5 plus 2 is 7 to the 0 power. Okay. Basically my parentheses are clear because honestly, I don't need, since I did the 5 minus 2, I don't need those parentheses on there anymore. There's no operation inside of those parentheses, so they're clear. So now I'm down to 3 to the 5th power times 3 to the 8th power plus 7 to the 0 power. Well, remember, anything to the 0 power is 1, so I'm just going to go ahead and put that 1 there. He's taken care of. Now let's use that trick of a to the m times a to the n is equal to a to the m plus n power. So I have a 5 exponent, because my bases are the same. That's why I can use this rule, right? So we know it's going to be a 3 to the something. So here my bases are the same. I have a 5 and a negative 8. 5 plus a negative 8. I have $5 in my pocket. I owe you 8. I'm still going to owe, right? So it's going to be negative 3. I still owe 3. Okay? Now remember in early in the lesson when we had these negative exponents, right? We went ahead and just turned it into a fraction. 1 over 3 to the 3rd. Now we don't have the negative fraction. The flipping it over reversed that. This 1 just comes from here. And I have 1 over 3 to the 3rd power. 3 to the 3rd power is 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 is 27. Add 1 to that, and you're going to get 1 and 1 to the 27th power. So rather than, the biggest trick use here was this guy, right? Because rather than find out what's 3 to the 5th, okay, now what's 3 to the negative 8th? Okay, now let me multiply those both together. We use this trick to make it nice and simple. All right, one more example, and then you can adventure off and try wrestling with this a little bit on your own. Just know you'll wrestle with it. You'll fall and struggle and everything, but let your brain digest it a little bit. So again, order of operations, parentheses need to be cleared first, and I have these brackets, which is just like a daddy set of parentheses really, right? So I'm going to clear my parentheses here and here first. This gives me 6 minus 1 gives me a 5, and I'm going to put everything else there, well, except for that inner parenthesis now. I still have to the 2nd power. I haven't done that yet. Now those daddy parentheses can turn to regular parentheses. That's my top part. Bottom part, I have a 3 plus 2, which is 5 to the 3rd power. Now I don't need those parentheses on there. Okay. All right, I have to remember my rule when it comes to something like this, and I would look back at page 36 and see that I have that a, when you have a to the m power all raised to the n power, I can say a to the m times n power. So I'm going to do 5 to the 2 times 2 power in this case. These mn, 2 times 2, which is 4th power. And then I haven't done anything with this guy. I'm going to keep him as 5 to the 3rd. Okay. Now, I remember a rule about division with these exponents. If your base is the same, let me look back at page 36. Oh, yes, that's right. If I have a to the m over a to the n, I can do a to the m minus n. So I have 5 to the 4th divided by 5 to the 3rd, and that's the same as the base raised to the 4 minus 3 power. And 4 minus 3 is 1, and 5 to the 1 power is 5. And wasn't that way easier than solving what 5 to the 2nd power was, and then getting that to the 2nd power, and then solving what 5 to the 3rd power was, and then dividing this ginormous number by this gigantic number, and then coming out and ending up with 5, because you would have ended up with 5 after all of that. So these tricks kind of help you be able to take some shortcuts. So this lesson is about getting familiar with those tricks. Post-it note or some sort of bookmark or something onto page 36, because you'll be flipping back to that a lot for a little while until your brain just internalizes these and realizes these are useful.